Chapter 8 is all about confidence intervals. So again, you will learn 3 sections for this chapter. Uh, 8.1 is confidence intervals for population mean, and the population standard deviation is known. These are the objectives. Construct and interpret confidence intervals for a population mean when the population standard deviation is known. Find critical values for confidence intervals. Describe the relationship between the confidence level and the margin of error. Find the sample size necessary to obtain the confidence interval of a given width. And distinguish between confidence and probability. Okay, point estimate. An example here, a simple random sample of 100 fourth graders is selected to take part in a new experimental approach to teach reading. At the end of the program, the students are given standardized reading tests. On the basis of past results, it is known that the scores on this test have a population standard deviation 15. So here, as you can see, given the population standard deviation, which is equal to 15. The sample mean score for 100 students was 67.30. The administrators want to estimate that the mean score would be if the entire population of fourth graders in the district had enrolled in the same program. And again, they only use 100 students out of the total population, and they get a sample mean of 67.30. They want to use it for the entire population of fourth graders. And of course, the best estimate is the sample mean. So that's why for this section, the sample mean is the point estimate because it is a single number. So take note of this. Copy this. The sample mean is a point estimate. Okay, it is very unlikely that the sample mean 67.30 is exactly equal to the population mean. So therefore, in order to estimate to be useful, we must describe how close it is likely to be. So for this example, they were able to get the interval. So not exactly 67.30. So let's say it could be off by 10 points. So possibility 67.30 plus or minus 10. So when you subtract 67.30 minus 10, that is 57.3. And 67.3 plus 10 is 77.3. So when we do this, the plus or minus a number, that is what you call the margin of error. Okay, as you can see here, 67.30 is the point estimate, which is the sample mean, and plus or minus a number, this is what you call the margin of error. And this is what you're going to see for this chapter and other chapters like chapter 10 and some of chapter 12. All right, suppose we want to be 95% confident in our interval. We need to determine how large to make the margin of error so that the interval is likely to contain the population mean. So to do that, we use the sampling distribution of mean. Because last time, remember, you learned about central limit theorem. That is when the sample size is n greater than 30, that tells us that the sampling distribution is approximately normal, right? We use, when you use normal CDF, also from your last quiz, you change the mean. Mean is mu and standard deviation standard deviation over square root of n. So take note of this. So mean of all the means is equal to the mean, and the standard deviation of all the means is equal to the population standard deviation over square root of n. So that's why from the example earlier, if n, you have 100 students and given a standard deviation 15, so you will be able to solve for the standard deviation. 15 over square root of 100 is equal to 1.5. And that is our standard error. Now, next is we need to construct and solve a critical value. Constructing a 95% confidence interval. So begin with a normal curve. This is like a middle 95%. You remember that? So we need to find the z-scores. As you can see here, this is 95%. So what are the z-scores on the left side and the right side? And you know how to do that. Normal CDF. Oops, sorry. It's not normal CDF. It's z-scores. That is inverse norm. So remember, 95%, so this is 0.025, this is 0.025, that's 2.5% and 2.5%, so this is 0.025, 0, and 1. If you get this, you will be able to get negative 1.96. But for those of you who has, what you call this, when you use inverse norm, a center, left, right, center. If you use a center, you will be able to get these two answers, negative 1.96 and positive 1.96. So here, if you try this, you will be able to get negative 1.96. And if you try 95 plus 2.5 is 97.5%. You'll be able to get 1.96. Okay, so now you know how to get the critical value. These values, that's what you call the critical value. And you know how to get a standard error, which is standard deviation over square root of n. So to get the margin of error, you just have to multiply the critical value and your standard error. So margin of error is 1.96 times 1.5 is equal to 2.94. Sorry, I won't be able to erase those. Okay, so margin of error is equal to critical value times standard of error. So 1.96 times 1.5 is equal to 2.94. So that is your margin of error here. Copy this. So the formula is the mean plus or minus the margin of error, which is 2.94. So that is 67.3 plus 2.94. So if you subtract, that is 64.36. And if you add 67.3 plus 2.94 is 70.24. And also, I want you to copy the interpretation, because every problem now, from now on, you need to interpret the result. So to do this, since your confidence interval is 95%, you say we are 95% confident that the population mean is between 64.36 and 70.24. So copy that. You have to write just one sentence about it. So you usually change this. Whatever the given confidence interval, confidence level is. So let's say 90% or 98%. Confident that the population mean, this one, 8.1 is about mean, the next one about proportion, and so forth. So you're gonna change that also. Is between now your two answers between 64.36 and 70.24. Okay. Any questions?
Is the percentage based on the area?
Oh, it's the confidence level 95% is going to be given, and I'll explain more about it later. Okay.
Okay.
Any questions? All right, no questions. What's next? All right, so we're talking about now confidence level. Is it always going to be 95%? That's the most commonly used confidence level. So based on a sample of 100 fourth graders using the new approach to teaching reading, a 95% confidence interval for the mean score was constructed. So 95% is a confidence level. It measures the success rate of the method used to construct the confidence interval. If we were to draw many samples and each one to construct a confidence interval, then in the long run, the percentage of confidence interval that cover the true value of population mean would be equal to the confidence level, just like this. And I will also show you the other confidence level. 95% is the most commonly used. Next is like 90% and 98%. Okay, terminologies that you will see for this chapter and the next chapters. I want you to copy all this: point estimate, confidence interval, confidence level, and margin of error. Okay, I'll give you 3 minutes, or let me know when you're done. Okay. All right, you're all done. Okay, point estimate is a single number that is used to estimate the value of an unknown parameter. Confidence interval, that is your final answer. That is always an interval that is used to estimate the value of a parameter. You always have two answers here. That is after you subtract and you add numbers. Confidence level, that is a percentage between 0 and 100%. That measures a success rate of the method used to construct the confidence interval. And the margin of error, that is computed by multiplying critical value and your standard error. Okay, next, let's discuss how to find critical values for confidence intervals. And those are the z-scores. So although 95%, like what I said, is the most commonly used confidence level, sometimes you will want to construct a confidence interval with a different level. Like as you can see here, the table here, what if you see confidence level that is 90% or 80% or even 99.5% or 99.9%. So to solve this is just like what we did, what I showed you earlier. That is, think that this is like middle, let's say 98%, middle 98%. How to solve that? Or middle 99% or middle 90%. So for critical values here, think that you're solving for middle of that percentage. Okay, or if you want, always have a copy of this. But what if I give you 93%, which is not on the table here, or 92% or 88%? Sure, Kami. All right, so an example here. A large sample has a mean of 7.1 and a standard error of 2.3. Construct a 90% confidence interval for the population mean mu. So mean 7.1, which is your point estimate, and the standard error 2.3, and construct a 90% confidence interval. All right. So oops. Always think about this when solving for a confidence interval, that it is always equal to point estimate plus or minus the margin of error. Okay, so this is always the formula for this whole chapter 8. 8.1, 8.2, and 8.3 is all about point estimate plus or minus the margin of error. And since this section is about the mean, so the point estimate is x bar plus or minus the margin of error. And what's the margin of error again?
The product of critical value and standard error.
Yes, the critical value, that is your z. Since you want the middle, so that's why we solve it alpha over 2 times the standard error. This is the standard error, standard deviation over square root of n. So to solve this, mean is point estimate is the sample mean 7.1, So plus or minus 90%. If you go back to the table, or again, if you want to solve this, think about middle 90%. So this is 90%, 0.9. So alpha is equal to 1 minus 0.9. Sorry. Okay, sit down. So 1 minus 0.9 is 0.10. Yes. And alpha over 2 is 0.10 divided by 2, which is equal to 0.05. Okay. So that's why there's two sides here is 0.05 and 0.05. Okay. So that's why these is your Z alpha over 2. This is also your Z alpha over 2. This is negative. This is positive. Okay, so like what we did earlier, so all you have to do here is inverse norm. So this is 0.0501. What is the answer? Try this. For those with a calculator, what's your answer here?
-1.64.
Yeah, so this is a special case. Use 3 decimals here because this is exactly 1.645.
Okay.
Okay. So there are, I think, 2 more, and I'll tell you when we use it. So if it's 90%, always use this 3 decimals, 1.645. So this is negative. So the other one is going to be positive, right? So positive, negative 1.645 times the standard error given is 2.3. So this is 7.1 plus or minus. Let's multiply that. 1.645 times 2.3 is 3.78. And then now the interval. Subtract this 7.1 minus 3.78.
The upper bound, Professor, is 10.88.
All right.
Oh, you got it.
Yeah,
0.9. Okay.
What is it?
10.88 for 7.1 plus 3.78.
And when you subtract it,
Subtract it minus 7.1 is 3.31, 3.32,
all right, so 3.32.
3.32 and 10.88. Yeah. 2 decimal places.
So if you use a 1 decimal, 2.3 and 10.9. If you use 2 decimals, so 3.32 and 10.88. So don't forget, we use a symbol here, mu, because this is, we're talking about the population mean, mu. Okay? And how do we write an interpretation here? Do you remember? Remember, we are, your confidence level is 90%. So you need to change that. We are 90% confident that, what is it?
Population mean is between is between 3.32 and 10.88.
Okay, so that's how you interpret your results. So as you can see, I changed, I use a green. That's when you use this sentence. This is like a sentence frame. Then you just change the confidence level if you have a different given confidence level. And also the population, this section is about mean. So you write mean and between what two values? That's 3.32 and 10.88. Questions? Do you have any questions?
Can we do another one?
Yeah, of course. We're gonna do more problems. To show, you just have to separate 7.1 minus 3.7835. You will get 3.32. The next 7.1 plus 3.7835. You just have to solve it separately. Okay, so there's no such thing as 7.1 and then there's no key step plus or minus 3, then 3.7835. Yes, our critical value is always positive. Yes, we get the, even if you get the answer here negative, use the positive, because you see here there's always a positive plus or minus. There's always a plus or minus here. So remember, this is our formula. Good questions. This is our formula. Point estimate plus or minus the margin of error. So yes, you can just use the positive 1.645 because understood we already have here plus or minus. Alpha is this, the rejection regions here that outside of the 90%. That's why we have this, when you subtract it from this 10% here, I'm gonna shade this two pink shaded regions, that is your alpha. Okay. All right, I'm gonna erase this. All right, so sometimes we need to find a critical value for a confidence level not given in a table, just like I already showed it to you, exactly how to solve it. And that is by using your graphing calculators, the inverse norm. So whatever given area, subtract it first from the given, and then just like this, let's have an example. So 92%, this is not on the table, right? So what we did earlier is 1 minus 0.92, which is equal to 0.08. Okay, and then alpha over 2 is 0.08 divided by 2, which is equal to 0.04. So we want to find z of alpha over 2. And z of alpha over 2. What do we do this again? Inverse norm of 0.0401. And what you get here? What is the answer?
Next.
Negative 0.75.
Yes,
Minus
negative 1.70. Yes, that's correct. Negative 1.75. All right, so here, meaning you have here on the left side here is negative 1.75, and on the right side 1.75. You got this, right? All right, so assumptions. Okay, from now on, for all the sections, starting this chapter, chapter 8, every section, there will always be an assumption. So for this section, these are the two assumptions. Yeah, we should always have a simple random sample, and n should be greater than 30. Or is stated on the problem that the population is approximately normal. Okay, so every problem we have to check using these assumptions. Okay, just like this. Next example. So a machine that fills cereal boxes is supposed to put 20 ounces of cereal in each box. A simple random sample of 6 boxes is found to contain a sample mean of 20.25 ounces of cereal. It's known from past experience that the fill weights are normally distributed with a standard deviation of 0.2 and construct 90% confidence interval for the mean fill weight. So let's check first with our assumptions. As you can see here, simple random sample and with the 6 boxes. So meaning n is equal to 6. Even though this is not greater than 30, but if you read the whole thing, it is stated that it is normally distributed. Okay, so meaning we can solve this. And given sample mean is 20.95, standard deviation is 0.2. So remember the formula, point estimate plus or minus the margin of error. And what's the point estimate again?
The mean,
Yeah.
the
It's always the sample mean. Okay, the point estimate is the sample mean plus or minus. We need to find the critical values here times the standard error. Sometimes we use SE. So the mean is 20.25 plus or minus the standard 90%. We used this earlier, right? What was the critical values for 90%? Hmm? What are the critical values for? We just used this. Yes, 1.645. Times. How do you get the standard error again? What's the standard error for? That's standard deviation. 0.2 is standard deviation. What is the standard error?
It's sigma over the square root of n.
Yes. So which is the standard deviation over the square root of your n. N is 6. Okay. So now this is going to be 20.25 plus or minus. Let's multiply that. 1.645 times 0.2 divided by square root of 6. And that is what you get. Point 134. Maybe anyway, I accept 2 decimals or 3 decimals. Okay, so since your mean has 2 decimals, let's use 2 decimals here also. Okay, so 0.13, so 20.25 so this is like 20.25 minus 0.13, 20.25 plus 0.13. You have to solve separately. So what's the answer here? 20 point
1, 2,
20 point what? 12?
3, 8. That's 1, 2, yeah.
Yeah,
Less than mean, less than 20.38.
20.38. Yeah. Thank you.
Okay.
So this is your confidence interval, 20.12 and 20.38. Okay, how do we interpret this again? Anyone?
We are
We are
9% confident that the population mean is between 20.12 and 20.38.
Yes, okay, thank you.
We are 90% confident because that was the construct the 90% interval.
That is correct. Or also, sometimes you can write, we are 90% confidence that the mean field rate, since if you want to be specific based on the problem, that the mean field rate is between 20.12 and 20.38. Okay. Any questions? You sure? No questions? Let's. Yeah, so we got this 20.12 and 20.38. All right, next one. I'm sure I was waiting for someone to ask, is there a shortcut for all of this? Yes. What's wrong? Yes, it's a lot of steps, but actually there is a shortcut. So, sorry, I had to show you all those ways how to do this. All right, so you ready for the shortcut? Okay, so when you use your graphing calculator, so stat, you just have to do this, stat, press stat, then test, and look for, since our critical value is z, so we're looking for a z interval here. Scroll down and look for z interval. I think that is number 7. And then what do you see? So you should see then highlight stats. And then you will see population standard deviation, the mean and n, and the sea level. You see this? So meaning you just have to enter all this, like this is 0.2, sample mean is 20.25, and n is 6. What's the given confidence level? It's 0.9, not the percentage. So use it in decimals, and then calculate, and you will see the answers. What do you see? What's the answer? You will see in parentheses, those are the answers. You will see 20.116, comma, 22.384. Do you see this? So meaning this is the interval. And also, I will accept if your final answer is like this, 20.116, 22.384. You just copy it from the calculator. But make sure that you know how to interpret this. we are 90% confidence that the mean field weight is between 20.116 and 22.384. Okay? So the shortcut stat has Z interval. That's all you need to do.
I got 20.384. Does that mean I typed something in wrong?
Double check your numbers.
Okay.
0.2, 20.256, and 0.90.
I got the same thing, both 20s.
Yeah, I double checked. I do have those numbers.
These numbers?
Yeah.
Okay. So again, you will see the steps here, how to use that graphing calculator. So test, stat test. Oh, yeah, here you will see exactly like this. Stat test Z interval, and you will see that the answer. Okay. Next one. Describe the relationship between the confidence level and the margin of error. So if you want to be more confident that our interval contains the true value, we must increase the critical value, which increases the margin of error. But there is a trade-off. We would rather have a higher level of confidence than a lower level, but we would also rather have a smaller margin of error than a larger one. Look at this with the differences between when you have 70% confidence level, when you have 95% confidence level, and when you have 99.7% confidence level. That's why we always use 95%. A lot of companies always use 95%. Or when you work on your research, a lot of people use 95% because this represents a good compromise between reliability and a margin of error. And yeah, so usually when you conduct a research, you always, you don't say that you are like almost perfect, right? That everything is almost perfect. And you don't say that yours is like 70%, that's too far from good. So that's why we use 95%. So the diagram presents 100 different 95% confidence interval. Look at this. When we construct confidence interval with level 95%, we are getting a look at one of these confidence intervals. All right, so for this section, another thing is finding the right sample size. This one has no shortcut. Okay, so you might ask if there is a shortcut for this. There's no shortcut for solving for a sample size. And copy this. And this is what you need to use. So from our margin of error formula, isolating n, it's going to be equal to this. The critical value of Z times the standard deviation over your margin of error squared. And don't forget this, since we are talking about a sample size, a sample, meaning we're talking about people, right? So after you solve for, after you get a final answer, and if you have decimals, you should always round it up. Do not round off, but you need to round up your answer. Okay, so example here. Scientists want to estimate the mean weight of mice after they have been fed a special diet. From previous studies, it is known that the weight is normally distributed with a standard deviation of 3 grams. How many mice must be weighed so that a 95% confidence interval will have a margin of error 0.5 grams? So how many? So that's why you talk about the sample size. So n is equal to 95%. What's the critical value of 95% again? This one thing, since 95% is the most commonly used confidence level, so you should know that this is 1.96. Okay, so that you don't need to always solve for middle 95% and then use inverse norm. This is one thing that you should memorize, 90 and 95%. So 95% is 1.96 times the standard deviation 3 over the margin of error 0.5 and then square it. Let's try that. What is the answer here? One 1.96 times 3 divided by 0.5. So you get 138.2976. And again, you see you have decimals here, and you should always round it up to a whole number. So n is equal to 139. Okay, because we don't have 0.2976 of a mouse. So how many mice? That is 139. Any questions? Okay, any all right, I think this is the last one. Distinguish between confidence and probability. Suppose the 90% confidence interval for the mean weight of cereal boxes was computed to be 20.12 and 20.38. This is what we got earlier. It is tempting to say that probability is 90% between those two. So the term probability refers to random events which can come out differently when experiments are repeated. So the numbers 20.12 and 20.38 are fixed and not random. The population mean is also fixed, the given, even if we do not know precisely what value it is. The population mean weight is either between those two intervals or it is not. Therefore, we say that we have 90% confidence that the population mean is this interval. So that's why we don't say probability. So we always, when we write our interpretation, you always write that with our confidence level. All right, so that's it for 8.1. And let's have some more examples. And this time, let's use the shortcut to solve confidence intervals here, which is stat test z interval. Okay, there's the you should see this chapter 8 problems. Oops, where's the ebook? Working with concepts. All right, 45. According to National Health Statistics reports, a sample of 360 one-year-old baby boys in the United States had a mean weight of 25.5, assumed that the population standard deviation is 5.3 pounds. So you have the mean 25.5, and you have a sample of 360. So using the assumptions, you have a simple random sample of 360, and it is greater than 30. And this section is all about confidence interval for means given the population standard deviation. So here, given the population standard deviation of 5.3 pounds. So letter A, construct a 95% confidence interval. So 95% confidence interval. We use stat test z interval. So enter all the givens. Standard deviation 5.3, mean 25.5, mean is 360, and confidence level 0.95. What's your answer?
I don't know if I'm doing this right, but on my calculator, well, I'm using one through the phone. I don't know if it's just like how it works on the phone, but it shows up as the standard deviation, the list, the frequency, and the sea level. Am I on the right track?
What is it?
All I see is, so when I do stat test and z interval, I only see like the input for the standard deviation, the list, the frequency, and the sea level.
Oh, the list. Because you have to highlight the stats.
Oh, now I see it. Now it's mean and the
Yes. Yeah.
sample. Got it.
So, yeah, I'm gonna show you later when to use that list. Okay. The next problem that I'm gonna show, we're gonna use that after this. Okay. So make sure to highlight stats so that you will be able to enter the mean, the standard deviation, the mean, and your n, and then the sea level point 95. Yes, so that is the correct answer. 24.953 and 26.047. So in our quizzes, in our quiz or test, you can just copy this is your answer. And I remember I told you that I always ask you to write the interpretation. So you can write here, we are 95% confident. I think it's more formal if you copy this. That we are 95% confident that the mean weight of all 1-year-old baby boys in the United States is between these two numbers, okay? Letter B. Should this confidence interval be used to estimate the mean weight of all 1-year-old babies in the United States?
Yes. Say yes.
Yes or no?
Yes,
Why?
because both the margin of error limits are less than 28 pounds. I mean, since 24.953 is less than 28 pounds and 26.047 is less than 28 pounds. So the range is less than 28 pounds. So it is likely that that is true.
Uh,
Oh,
that explanation is actually for letter C. Like she already answered letter C. Based on the confidence interval constructed in part A, is it likely that the mean weight of all 1-year-old boys is less than 28 pounds? Letter B, should this confidence interval, 24.95 to 26, be used to estimate the mean weight of all 1-year-old babies in the United States? And then explain. What do you think?
Would it be no, because we're only confident in 95%?
The answer is no, but there's another explanation for that.
Okay.
Any other explanation? What do you think? So the answer is no. So again, read it carefully. Should the confidence interval be used to estimate the mean weight of all 1-year-old babies in the United States?
No, because it's just baby boys.
Yes. Okay. So here our problem is just we're just talking about 1-year-old baby boys. But here the question is about all 1-year-old babies in the United States. Okay. So that's why it is a no. If they're very specific about all 1-year-old baby boys, then it's going to be a yes. Okay. So letter C, is it likely that the mean weight is less than 28 pounds? Yes, because as you can see that it is between 24 and 24.95 and 26.05. Any questions? No, our N is 360. Next problem. How about 47? So how smart is your phone? A random sample of 11 smartphones sold over the internet had the following prices. Assume that the population standard deviation is 85. So that's the first thing you check every problem. By the way, your final exam is, remember, from chapter 8 up to chapter 14. So starting this chapter. And this section, 8.1, is about when population standard deviation is known. Okay, so you check from the problem that the population standard deviation is known. Explain letter A why it is necessary to check whether the population is approximately normal before constructing a confidence interval. Okay, why is it necessary to check whether the population is approximately normal before we solve this? Because your N is less than 30. So remember, if it's less than 30, we need to check the given. So here, it's not stated in a problem that is approximately normal, but we can check this using a dot plot. So letter B, following a dot plot of this data, is it reasonable to assume that the population is approximately normal? Look at the dots. Do you see a normal curve here? Yes, it's evenly distributed, so meaning you can check that this is like has a normal curve. So it's approximately normal. Okay, so and then since based on this, meaning we will be able to solve, it is appropriate now to use to solve for the confidence interval. So as you can see here, we don't have the sample mean, but we have the data here. So we need to enter this first. Every time we enter the data, that is stat stat 1, and you will see L1. The first column, enter all these numbers into L1. I will do the same thing here. 199, 169, 3. So enter into L1, and then the shortcut stat test Z interval. Stat test Z interval. And this time, since you enter your data into list 1, L1, so you have to highlight list. Oh, data, sorry. There's no list. You have to highlight data. And then enter. You will see standard deviation, which is 85. And then you will see list. That is where you enter your data. Let's say the first column is L1, which is the default. Frequency, you don't change that. That is 1. C level, whatever the confidence level given. Is there a confidence level given? Yes, 95%. So that is 0.95. By the way, if you don't see an confidence level, meaning in any statistics books, it's understood that you use 95%. Okay, so don't forget that. If you don't see a confidence level given, you use 95%. What is your answer?
Professor, it's not letting me input any more information without putting frequency.
What do you mean?
It's listed input data, standard deviation 85, list L1, frequency, C level, and it's asking me for a frequency.
It's 1. It's the default 1.
Oh, okay.
Yeah. And what's your answer? Did you get that? Yes, that is correct. Okay, any questions? All right, no questions. All right, so 8.1, remember, population standard deviation is known. This time, 8.2, population standard deviation is unknown. So see the difference between these two sections, but we're still talking about the population mean. And these are the objectives. Only 2 objectives. It's going to be short. Describe the properties of the student's T distribution. 8.1, we use the Z distribution, meaning the critical value we solve for Z. This time we're going to use t distribution. And then we will be able to construct confidence intervals for this population mean when the population standard deviation is unknown. So let's talk about now the t distribution. So earlier we used this formula, the sample mean plus or minus the critical values of z times the standard error, standard deviation over square root of n. So it is rare that we would know the value of the standard deviation while needing to estimate the value of the population mean. In practice, it is more common that sigma is unknown. When we don't know what the value of the population standard deviation, we may replace it with the sample standard deviation. And when we use that, we use the student's t distribution. And whenever we use t distribution, we always use degrees of freedom, which is equal to n minus 1, your sample size minus 1. And this is what happens to your normal distribution. This the black one, this is standard normal with t with 10 degrees of freedom, 4 degrees of freedom, and 1 degree of freedom. It's still normal distribution. And now, how do we compute for the critical values of t? So, of course, we want to use for the shortcuts, right? Because we are solving for t alpha over 2. What do we use again from 8.1? How do we get the critical value? How do we solve critical value again? From 8.1? I remember we just talked about it earlier. How do you solve for critical value 8.1, the z?
Does that use the inverse norm?
Inverse norm, right? So for this one, critical value for t is we use inverse t. So if that is second worst, so this is by using a table, but since we don't have the table, how do we use a critical value using your my cursor? Look for inverse t. That I think that is the fourth one. So instead of inverse norm, you use inverse t. Okay. So remember, this is 95%. So 1 minus 0.95 is equal to 0.05. So this is your alpha. Alpha over 2 is 0.05 divided by 2 is equal to 0.025, right? So when you think about this, T alpha over 2, if this is 95%, this 2.5%, this 0.025, this is 0.025, right? And we want T alpha over 2, this negative T alpha over 2, this is T alpha over 2. So we want this. What is, when you use inverse T, you will see area, degrees of freedom, two things, area and degrees of freedom. The area is to the left of T alpha over 2. So meaning the whole thing here, 95% plus 0.025. So that's why you have to enter here 0.975. And degrees of freedom, df, is always equal to n minus 1. So don't forget this. So the sample size is 10. 10 minus 1 is 9. And then now you will be able to get the answer. What is the answer?
I have the parentheses. So in the parentheses, you type in the area, the DF, and the
These
sample
two.
size.
Yeah, these two, yeah.
Oh,
Degrees of
just those two.
just these two, yeah.
Okay.
0.975 comma 9.
Okay.
Okay, yeah. So yeah, 2.26. So that's how you get the critical value. So again, please don't forget, do not enter 95, but you have to enter, when you divide it by 295 plus 0.025, so that's why you enter 0.975. Okay, any questions? And we have assumptions here. Copy the assumptions. It's the same thing. You don't need to copy, sorry. It's the same thing. So we have a simple random sample and the sample size is large, must be greater than 30, or the population is approximately normal. And just like what we did at the previous example from the book, if it's less than 30, you can use a dot plot. And if it shows this one, a simple method is to draw a dot plot or a box plot of the samples. If you see a shape of a normal curve, then you can solve for the confidence interval. But if you see like skewed to the right or skewed to the left, then you won't be able to solve for the confidence interval. You can stop and do not solve for the confidence interval. Okay, the next objective is solving for the confidence interval. So there are two ways. The first one is by using the table, and the second is the shortcut, of course, using the TI-84. And let's use a TI-84 with those two problems. So this time, since we're using T interval, T critical values, so we're using T interval. So stat test, scroll down and you will see T interval, that is number 8. And if given statistics on this problem, you will see a sample mean, sample standard deviation, N, and the confidence level. If you have the data given, then you have to highlight data, enter it into L1. So just like this one, a food chemist analyzed the calorie content for a popular type of chocolate cookie. Following are the numbers of calories in a sample of 8 cookies. You have 113, 114, 111, 116, 115, 120, 118, 116. Find a 98% confidence interval for the mean number of calories in this type of cookie. So I'll show you when you use a dot plot here. These are the dots, and you'll see that it looks like approximately normal, right? So therefore, we can proceed and solve this. So to solve that, again, stat 1, enter this into L1, all these numbers. So enter those numbers, and then after that, you have stat test t-interval. And this time you highlight data because you enter those data. You will see lists. That should be L1. That's where you entered your data. Frequency, the default is 1. Sea level is 98%. So don't forget to change that to 0.98. And Lei has already an answer. 112.38 and 118.37. Did you get the same answer? Yes. All right. So how do you interpret this results? Anyone? How do we write the interpretation here? We are, your confidence level is 98%. So 98% confident that, what are we talking about here? Is always on the last sentence. You construct a confidence interval for the mean number of calories. In this type of cookie, you can copy that, or per is between 112.38 and 118.37. Any questions? Next one. Who wants to read the problem? I need the volunteer, read the problem.
I can do it.
Yes.
A sample of 123 people aged 18 to 22 reported the number of hours they spent on the internet in an average week. The sample mean was 8.2 hours with a sample standard deviation of 9.84 hours. Assume this is a simple random sample from the population of people aged 18 to 22. In the US construct, a 95 confidence interval for standard deviation, for mean, the population mean number of hours per week spent on the internet by people aged 18 to 22 in the US.
Thank you. So based on this problem, what data do we have? We have a sample of 123, so meaning this is your N. Reported number of hours is spent. The sample mean is 8.20. Sample mean meaning this is your X bar. Sample standard deviation, this is S, 9.84. And you need to construct a 95% confidence interval for mu. So for mu, meaning you're talking about 8.1 and 8.2. And this is 8.2 because it doesn't say that you have the population standard deviation, because you have a sample standard deviation. That's why this is 8.2. Okay, so make sure that you know, because during the final exam, it's going to be a mix of all the problems from chapter 8 up to chapter 14. So the first thing to check is, there are only two things to check for the first one. Is it confidence interval or hypothesis testing? Hypothesis testing starting chapter 9. So when you see the word confidence interval, you would know that this is from this chapter. Okay, and here I encircle this because it's mean or proportion. The next one is proportion. All right, so here, this confidence interval, so we want to solve for 95% confidence interval of for mu. So again, this is stat test T interval. And then this time highlight stats because you have those data. And I'm gonna do the same thing. Stat test T interval, highlight stats. The mean given 8.2. SX, that is your standard sample standard deviation, 9.84. N is 123. C level or confidence level is 95%. And the answer? What is your answer? And 9.96. You can use 2 decimals, 3 decimals, or the whole thing. I will accept everything, okay? All right, then don't forget your interpretation. How do you interpret this? Anyone who wants to say it? how do you interpret this answer?
We are 95% confident that the population mean number of hours per week spent on the internet by people aged 18 to 22 in the US is between 6.44 and 9.96.
Yes, very good. Thank you. All right, so I think that's it for 8.2. Yeah, that's it for 8.2. So that's why I said it's a short one. And maybe let's solve one problem from the book. Where is it? Which one? Fake Twitter followers. So many celebrities and public figures have Twitter accounts with large numbers of followers. However, some of those followers are fake, resulting from accounts generated by spamming computers. In a sample of 46 Twitter audits, the mean percentage of fake followers was 14.1 with a standard deviation of 9.6. So A, construct a confidence interval for the mean percentage of the Twitter followers. So again, you have the sample mean and the sample standard deviation here. Your n is 46. It's greater than 30, so we don't need to check or use the dot plot or box plot. So stat test the interval. And then highlight stats. What's your answer? Mean 14.1, standard deviation 9.6, n is 46, sea level is 90%, so that is 0.9. What did you get? So yes, 11.723 and 16.477. That's what I get to. So 11.723. All right, so based on letter B, the confidence interval, is it reasonable that the mean percentage of fake Twitter followers is less than 10? What's the answer? Is it reasonable that the mean percentage of fake Twitter followers is less than 10?
No, because the lowest is 11.7.
Yes, the answer is no, because it's not within the interval. Your computed interval is from 11.7 to 16, and less than 10 is not. So Yes, the answer is no. Okay. All right, so it's almost time. Most of the problems are the same. You just have to use stat test interval for this. It's either you highlight data or stats data when you need to enter the data, and stats when you have all this mean, and sample mean and sample standard deviation. Okay. So also, if you want, you can try these problems, and you can ask me anytime if you have any questions. And you should be able to answer the first 2 sections of homework, Connect Math homework assignments.